Hi, hello, my name is Niroj. My student ID is BSCPCS63134. In this presentation, I'll be discussing the data science task I worked on for the HD1 task for the SIT112 module. So, if you see here, the main focus of this task was on the analysis of the regression between the dependent variables, which is the common sentiment, and the independent variable, which is the video title, video likes, and video duration, from the dataset that was collected on analyzing YouTube videos about COVID-19 published by at least 4 newspapers, which are like then Fox News, BBC, CNN, MSNBC. This was given a start date and an end date. So within these dates, the dataset will be collected. The main objective of this analysis is the data we get from this regression analysis can be used to predict the sentiment, trend, and outcome of the datasets we collect in future. So we can like use this as a model, and using this model we can predict the datasets and videos we collect in future. So for this I had used two CSV files, one video CSV file and one comment file, or comments.csv file. The videos files contain video title, video likes, and duration of the video. The comments file has the comment text data. With all this data, the main data science task I worked on was that I first clean the data, then I had to like merge them. The codes are given here. Merge them and prepare them for analysis, and use scatter plots to visualize the relationship between the dependent variable and the independent variable of the table. So now let's see how the data is being cleaned in this analysis. So first, if we see, here's the code I've used to clean the data is given here. So if we see this code addresses common data quality issues like punctuation, digits, case variations, duplicates, missing values, and language inconsistencies, enhancing the data's readiness for analysis. It standardizes the text for better analysis by removing stop words I've given here, and which can often obscure meaningful patterns and relationships. This also filters English commands, suggests a focus on English language analysis, and the function's structure allows for incorporating additional cleaning steps or modification as needed, depending on the specific analysis requirement. As I mentioned before, this cleaning code involves removing inconsistency, handling missing values, and standardizing text for better analysis. So now let's take a look at the code line by line for better understanding. So here we see that this clean data function aims to clean and prepare video and common data for further analysis. So if we come down further, we can see that this is where the video file is getting loaded onto the data frame as video, and here we can see that the video file data column video title inside the video file is getting cleaned by using this apply lambda function, and inside the lambda we use the sub and lower function. Each line has a specific function to them. Like the first line removes the punctuations in the video titles, and second line removes the digits in the video title, and the third line converts the video title to lower cases. And all these cleaning are done for better analysis and consistency in the data. So after doing all this, we save the file into the same video CSV file for applying any changes we made. So we actually made a few changes on top here on the video file. So we are applying the changes on the same file and making sure the original file is having the changed or the altered cleaned data. Then going further down, we do the same procedure to the comments file as well. So the comment text column in the comment file will be more specific. We remove the punctuation, digits, and convert them to lowercase. And in for the comments, we have something extra additional in that is that we remove the duplicate values and the missing values. So the duplicate and missing values will definitely produce inconsistency in the data. So to prevent that happening, we use the drop duplicates function and drop now function in the commands file to drop the duplicates and missing values in the dataset. Then I use the try except block to filter out the comments that are not in English. So in case if the comments given in the comment section is not in English and in a different language, it's hard for us to uh, find an analysis on that and come up to a conclusion. So for that, we are using only English language for the consistency of the data. So the data can be more consistent and analysis will also be more reliable. So in that case, if it's not an English word, it says it non-English comment and skips to the next line. And I've used the stop word removal as well. So this will remove the some common and uninformative words from the comment text using a provided list of stop words. Then as usual, it also saves the files to the original file, applying all the changes we made. And at last, as type function is given to the comment text. So just to ensure that the comment text is in string format. Move on to the data preparation. So in this, what we are doing is that the main focus of this code is like the code emphasizes time-based analysis by creating summary columns for weeks, months, and year. It highlights the importance of converting data types and formats for meaningful analysis. And it demonstrates how to combine multiple data sets to enable integrated analysis. In detail, in-depth look at this code. Let's see that this code prepares two data sets like video.csv file and comment as usual for the previous part. So what it does is like cleaning and formatting data related columns. That's the main thing it does here, and converting video duration to numerical values for calculations. Here it's this code is done here, and create summary tables based on time periods on top here, and merging the data sets for integrated analysis. So if you see each code line by line, the first code reads the CSV files into the pandas data frame, and is convert the formats date like this. The first line actually converts the video DF to date time format for date-based operations. Here we are creating new columns called we published at weekly, monthly, and yearly. So we can extract week information for weekly analysis and month information for monthly analysis and year information for yearly analysis. And this is done on the video file, videos.csv file, and we are doing the same thing for the comments file as well. We are changing it to the date time data type, and then extracting the week information for weekly, month for monthly, and year for yearly. So just like I mentioned earlier, this code is used to convert the duration in the videos DF from a text format as given here, text format to the seconds for numerical analysis. Then at last the videos and comments are getting merged, creating a combined data set for the videos and comments for better analysis and actually better and easy analysis. So now let's take a look at this piece of code. This is a pretty different one. What this code does is it takes a text input and returns its sentiment polarity score and sentiment category, whether it's positive, negative, or neutral. So this is like one of the main code that's we are going to use for this task. So what it does is the main purpose of this code is like the code provides two functions for analyzing sentiment. One is this one, get sentiment score, and the second one is get sentiment. What this get sentiment score does is it checks for null values. So if the text is null, it returns 0, which means a neutral sentiment. The sentiment in that text is neutral, 0. Otherwise, it uses the text block library to create a text block object from the text, then returns the sentiment polarity score from the text blob object, typically between a value between like -1 and 1. Then what this get sentiment does is this also takes input as an argument and checks for null values. If the text is null, it returns neutral. Otherwise, creates a text blob object and extracts its polarity score. Then it categorizes the sentiment based on the polarity score. Here, just calculates the polarity score. Here also, at first it calculates the polarity score, but now what it does is going to categorize the polarity score. So if the polarity score is more than 0, it returns a positive. So the sentiment of that comment is positive. And if it is less than 0, the polarity score is negative. Otherwise, if it is neither positive nor negative, it's going to obviously return a neutral neutral score. So if we see that this code demonstrates how to use the text blob library for sentiment analysis. It handles like null values gracefully, avoiding errors and assigning neutral sentiments. And it provides both a numerical score for fine-grained analysis and a categorical label for easy interpretation as well. So this function can be applied in not only this but in various text analysis tasks as well.